Hello, my name is Dave Reisfeld, and I'm a customer engineer with Google Cloud. In today's session, we're going to talk about modern content delivery at scale. Our agenda for today's session is a brief introduction about CDNs in general and what is Cloud CDN, and then we're going to talk a little bit about some of the new features that have recently been released on Cloud CDN. We're also going to talk about some adjunct capabilities that support Cloud CDN and really help provide additional functionality for your configurations. And lastly, we're going to talk a little bit about some upcoming platform enhancements that we're making to both Cloud CDN that I think you'll be really interested in seeing. So, jumping right in, what is Cloud CDN? So, before we kind of go there, let's talk a little bit about what a content delivery network is in general. A content delivery network is a series of web servers that are designed to deliver content close to end users. Generally speaking, when customers look to use a content delivery network, they're really looking to get access to one of five key benefits: some performance benefit by serving content close to end users, global reach, being able to expand beyond their origin infrastructure and having the CDN give a point of presence, high availability, ensuring that there's no single point of failure in the delivery chain, scalability, both in terms of vertical and horizontal scaling for planned and unplanned event activity, but also from a security standpoint, both in terms of secure content delivery, but also in terms of denial of service and security mitigation capabilities. So, Cloud CDN is Google's content delivery network that has been designed for accelerating web and video content. The Cloud CDN platform has been built to support Google's exacting needs. And what I mean by that is the Cloud CDN platform that you use on Google Cloud is the same platform that Google uses for delivering search results, for delivering Gmail results. So you know that this is a highly performant and highly scalable content delivery network platform. Specifically, as it relates to Cloud CDN, there are various performance capabilities that we embed into Cloud CDN. Things, for example, like the industry leading time to first byte. These are a lot of the technical kind of nuances that we bake into the Cloud CDN platform to ensure fast response time, fast throughput time. And a lot of that comes around from Google innovation. Things like Speedy, that manifests itself as HTTP2. We also look at things like QUIC and how that is quickly morphing into the new HTTP3 protocol. But you also can look at new standards in pacing, for example, like the BBR functionality that you can find in Cloud CDN that was first developed at Google. Global reach. The Cloud CDN platform consists of over 140 different edge locations around the world in 35 different countries. This ensures that you can have a point of preference anywhere around the globe where your end users are located. From a high availability standpoint, Google backs up our Cloud CDN platform with an SLA, a 99.95% availability SLA, to ensure that you always have your content delivered and it's always going to be available on Cloud CDN. In terms of scalability, the Cloud CDN platform is a multi-terabit per second content delivery platform. This is an active platform delivering terabits of data on a daily basis today. This is not a new platform, but this is simply the commercial use of Google's existing content delivery network platform. And lastly, from a security standpoint, Cloud CDN supports both PCI and HIPAA-based workloads. You also have the ability to customize TLS handshakes, whether it's in terms of specific CIDRs or specific TLS protocols that you want to use. One of the highlights of Cloud CDN is the network. So many of you have been familiar with the Google data centers within the cloud program, but added to that are the edge CDN nodes distributed around the globe. Some of those locations are within Google Cloud data centers where you're doing compute today, but we're also in other satellite locations to extend the reach of the platform. Interconnecting all of those nodes are Google controlled fiber. So, unlike some other competitors in the marketplace, Cloud CDN interconnects all edge nodes with Google controlled fiber. So when there is a cache miss on the edge server, you are routed your request back to the Google origin location across Google controlled fiber. And this is a key differentiator of Cloud CDN. Now, in our next segment that we're going to discuss today, I want to highlight some recent releases of the Cloud CDN platform. Specifically, there are kind of two areas of focus that we really want to kind of segment content through. There's performance characteristics and there are feature enhancements that we've recently released. The first feature we want to talk about is TLS 1.3. This was recently released in April of this year, where the entire fleet has been upgraded to support TLS 1.3. One of the main benefits of TLS 1.3 is it is faster. It's about 40% faster over TLS 1.2. And that really translates itself in time to first byte, right? By reducing the number of round trips a client needs to make with a server in order to establish an SSL connection, the faster we can start delivering the payload, the content that the end user really cares about. One of the other enhancements that's made to TLS 1.3 is that it's removed some of the obsolete and insecure ciphers that have been found in previous versions of TLS 1.1 and 1.2. Approximately 80% plus of end users can support TLS 1.3 today. So in order to take advantage of this, there's nothing that the end user needs to do. Their browsers already support it. Cloud CDN just makes this available as a protocol option for the end user to communicate with the Cloud CDN server. The next feature we want to talk about is custom origins. Prior to the release of custom origins, the only way for content to be fulfilled on Cloud CDN is through infrastructure, through content that's actually hosted and domiciled on Google Cloud, whether that be a storage instance or a compute instance. With the introduction of custom origins, you now can attach third-party origins that are not part of your Google Cloud tenant in order to have that be delivered by Cloud CDN. So this now gives you the ability to extend the life of your existing origin infrastructure and still support Cloud CDN. This also can be useful as part of a migration strategy. As you move content into Google Cloud, you can use Cloud CDN as a bridge to kind of obfuscate your origin infrastructure, migrate your infrastructure into Google Cloud, and then change the pointer of the backend. So this becomes a huge enabler for not only Cloud CDN, but also as part of a content migration strategy. The other thing to kind of point out here as a differentiator is with the custom origins, we support not only HTTP, HTTPS 1.1, but we also support HTTP 2. So while the end user client to the Cloud CDN Edge can support HTTP 2, many other content delivery providers downgrade the protocol from the edge talking back to an origin. With custom origins, you have the ability to maintain the HTTP protocol from edge all the way to the origin. So you can take advantage of head-of-line blocking and multiplexing capabilities of the HTTP2 protocol. From an integration perspective, something to be cognizant of is with these third-party origins, they still must be publicly available. So you can't use an RFC 1918 private IP address for this. It still must be a publicly available IP address. Subsequently, that web server also needs to be an HTTP-oriented web server, whether it's HTTP or HTTPS, in terms of its protocol exposure. So you can't use any like a UDP style protocol there. The next feature I want to highlight that was recently enhanced to the Cloud CDN platform is along the lines of access control. Now, prior to the release of signed cookies, we always could support query strings as a way to mitigate the content access and to help help prevent the hyperdistribution of content. we've now introduced the ability to support signed cookies. So not only can you use query strings or signed cookies, you can actually use them together as a way to provide a more comprehensive content protection strategy. Generally speaking, though, if you think of how the access control works today, there are three core elements to be cognizant of. There's epoch time. This is the time of the expiration of the URI asset. There's the key. By default, Google can support up to 3 keys simultaneously, and you can rotate those keys at will through your Cloud CDN configuration. And lastly, there's the hashed value that you use to kind of create that kind of secured token value based on the key and the URI path that you want to incorporate as part of the security check. All 3 things need to be present as part of your access control to prevent the hyperdistribution of the URL. Now, one of the things that's unique about Cloud CDN is that there are other ancillary functions within Google Cloud that actively support the Cloud CDN service. So if you think about how Cloud CDN comes to life, it leans on these other capabilities of the wider portfolio to enhance the offering. In this portion of our discussion, I want to kind of highlight a couple of those new features that were recently released that provide additional functionality to the Cloud CDN user experience. The first feature we want to talk about is redirects and rewrites. And this particular function is an extension of the Google Global Load Balancer. Today, we now have the ability to perform redirects and URL modifications. Prior to this, you had to do any sort of rewrites or URL modifications on your origin infrastructure. With this new release, the Google Global Load Balancer has the ability to dynamically do the rewrites or redirections. We see this quite often in terms of use cases for things like HTTP to HTTPS modifications. We also see this as part of a URL shortener strategy, where you might have a short, friendly URI path for marketing purposes, but behind the scenes, we want to explode the URL to actually point to the actual origin destination. The next feature we want to talk about as a highlight and extension to Cloud CDN is on logging. More specifically, there are 2 edge cases that we want to highlight here. Number 1 is the edge cache status. Prior to this release, the Cloud CDN platform never exposed the behavior of the edge cache, whether or not we served it from cache or we had to fetch that from the origin. With this latest enhancement, we now expose this information to you in the log line. So you now have the ability to see whether or not the actual edge cache served it from its own stores or disk, or if we had to fetch it from the origin. This can be important in helping you figure out your optimized content offload strategy. And so you can set alerts, you can set monitoring against these data attributes in the log line to help improve your offload rates. The other enhancement that was recently released inside the log lines is the IATA code of the Google Cloud CDN edge server that did the delivery. The IATA code is kind of a 3-character code, sometimes is referred to as like the airport code of where that Google Cloud CDN edge server actually resides. So the idea behind this is you have some visibility as to how Google is actually delivering your content to end users. Now, mind you, this is not the actual destination of where the end user is located. This is merely the edge server that was used to fulfill that specific edge request. The next feature I want to highlight here is Cloud Armor. We've recently now enabled Cloud Armor to work with the Cloud CDN origin infrastructure. For those of you that are not familiar with Cloud Armor is Google's inline security offering for WAF and network layer protection. And this is designed to help protect origin compute resources. Specifically within Cloud Armor, it supports OWASP mod security rules, but it also supports IP whitelisting blacklisting, as well as country level IP whitelisting blacklisting. The benefit of using both Cloud Armor and the CDN platform together is it gives you fantastic volumetric protection, but it also provides presentation layer protection such that you can now protect origin workloads and deflect requests that have been detected by the security rules or your IP or country list blocking schema, so that your origins don't need to deal with those requests that we know are basically of malicious intent. The other benefit of working with Cloud Armor and the Cloud CDN platform together is that the messaging for Cloud Armor is directly embedded within Google Load Balancer log lines. So with both of these solutions in place, you have a single source of truth where you have visibility in terms of what is allowed or denied. And if we denied or allowed a request, you can see the policy rule from Cloud Armor that specifically was being enforced in order to affect that specific logline request. Now, we'd like to turn a little bit into the second half of the year. What are we intending to bring to market within Cloud CDN? The first feature I want to highlight is flexible cache control. Within flexible cache control, there are three core capabilities that fall under this umbrella. There's cache control, there's header manipulation, and there's error handling. As we talk about cache control, before the flexible cache control release, cache control header values need to be dictated by your origin web server. And many customers have complained that that was not how they wanted to control the cache setup. With the flexible cache control release, the Cloud CDN platform now will have the ability to apply cache control rules on the CDN platform itself. This will help improve the cache offload rates by you no longer having to manipulate your origin web server, but it also simplifies the workflow process where the CDN automatically will apply the rules rather than you having to be more specific about your work and path and header manipulation within your web server configuration. Specifically, from an integration standpoint, we will have three main setting options. So we will still maintain origin cache control values, and that still will be available to you, but we're going to add two new capabilities for being able to serve cached objects, for static objects, as well as the ability to just simply cache everything, where in this case we will ignore whatever decoration the origin is supplying in terms of cache control header values, whether it's private, public, etc., and we'll just apply our own TTL setting values based on your configuration setting. In the case where you're using cached static objects mode of operation, what we will do is we will apply the cache control values that you dictate in your CDN configuration based on specific MIME types. And those MIME types are listed here on our slide. The third component, or the second component we want to talk about within flexible cache control is header manipulation. And within header manipulation, there are a couple of different use cases that will be addressed with this release. The first one is the ability to add downstream response headers to the end user client. This is helpful for things like adding coarse header values, which can be important for streamed objects or JavaScript objects that require additional helper module, like helper directives, to allow the browser to leverage the particular object that is being delivered. The next capability within the header manipulation bucket is the ability to bypass a cache on a header request. And this can be helpful to distinguish between an authorized and an unauthorized user, or it could be used to determine things like a logged in or a logged in user. So for example, you might want to have a cached page experience for unauthenticated users. And in the case where you have a more personalized experience and the user actually is authenticated, you might want to bypass the cache and go directly to the origin for a more customized experience delivered up from the origin itself. The third use case under the header manipulation is the ability to restrict the methods that are being used. So by default, Google is going to allow all different method types to get funneled into your origin web server. With this new capability out of the flexible cache control, we now have the ability to be more prescriptive in terms of what feature method types that we want to allow into the origin. The benefit here is that this will allow you to tighten up your security policy. So, for example, if your website doesn't accept post requests, then we can specifically deny post requests on the CDN edge rather than funneling those requests all the way back to the origin, where potentially it could be ripe for vulnerability or exploitation. The other part of this, when we talk about things like adding course headers, it helps enrich the client request experience so that we can take advantage of capabilities that are native inside the browser, such as CORS capabilities. The third extension of the flexible cache control is error handling. Prior to the release of flexible cache control and the error handling module, the Cloud CDN platform would pass through whatever error it was handed to it from the origin. And this kind of manifested itself in reduced site availability. We're making modifications to the way that Cloud CDN behaves to enhance your site availability. The first extension of that is with negative caching. So specifically, if you advertise certain HTTP status codes from your origin, we have the ability to actually cache those requests to help buffer your origin from these responses. The second extension, specifically around error handling, is the ability to serve stale content. So by default, when an end user request is made to the Cloud CDN edge, we're going to make the determination if we have that content, we'll serve it. If we don't have that content, but we have the object sitting in cache, we're going to consult with the origin for revalidation of that object of whether or not we can continue to serve that out of our cache. In the event that the origin isn't available, we would, in the past, serve up an error response. With this new capability, we now have the ability to serve that stale content rather than serving up the error page. So this is going to, again, help increase your website availability, but it also helps buffer your origin at times of high load. From an integration perspective, some helpful tips to kind of share with you. So first off, by default, Google will be turning on serving of stale content by default. The TTL default value is 1 day. So in the event where we have an object in our edge cache and we can't revalidate it with the origin, the default posture will be to serve out stale rather than serving up an error message. Subsequently, the negative caching will be an opt-in feature where it will be available to you, but you must elect to configure and turn that behavior on in your configuration set. That negative caching will not be enabled by default. In our next level of enhancements that I would like to discuss with you is around platform enhancements. And the first feature we'll want to highlight is resource coalescing. With resource coalescing, this helps particularly with things like live streaming, when we have lots of requests all looking for the same object. In the past, each request would be treated individually. With resource coalescing, or sometimes called request collapsing, we have the ability to fulfill that request from multiple edge requests from a single request and share out that response to the edge server rather than making lots of individual requests. This helps with content offload from the origin, and it also helps with content scaling for high volumed events. The next platform enhancement that I want to talk to you about is TCP enhancements. So, as part of our recurring kind of theme of always improving our time to first byte and also improving our throughput response rates, we are making modifications to the way that Cloud CDN will interact with the end user client. All of this is invisible to the end user. All of this is invisible to you from a configuration standpoint. It just magically will get better. Specifically on the TCP enhancements, we're making modifications to our throughput, but we're also making enhancements to our pacing. So today, we're using pacing from that leverages BBR, for example. One of the things that we're looking at adding into the platform in the second semester is looking at adding the BBR version 2. Again, another advancement coming from Google. The next item that I want to talk to you about is HTTP3. So today we support QUIC, more specifically GQuic. And this can be found already embedded and it's already enabled on Chrome and latest Firefox browsers today. And this is now enabled on your platform that you can enable and opt into in your Cloud CDN configuration. But we're not stopping there. We are now going to be extending the QUIC platform from GQuic, and we're transforming that to iQuic, which is now the new standard for the QUIC protocol. The iQuic is kind of a precursor of sorts to the HTTP3 protocol. And as we start to roll out iQuic and the HTTP3 protocol to the entire Cloud CDN fleet, Cloud CDN customers will automatically have the ability to leverage this new protocol. The benefit of using the HTTP3 protocol is going to improve not only your time to first byte, but also improve the client performance and stability for end user clients, particularly on unstable networks. So, in summary, the Cloud CDN platform is making a lot of investment in our platform, not only in terms of enhancing and adding new features and functionality to the Cloud CDN platform, but we're also looking at extending our industry leading performance characteristics and capabilities. Likewise, we're also making additional investments in Cloud CDN to revamp the user experience. So it's going to become easier and more enriching environment for you to use Cloud CDN without having to go to multiple different screens. And with that, I want to thank you for attending my presentation today, and I welcome to see you on a future presentation.